Hello there. In this video we are going to see how to transform the data into the logarithm form in order to improve the results. We have seen the results before, we have seen the relationship before, and now what we're going to do as a first step is to create the new dataset. We are actually creating the new dataset, but it's going to be the copy of the dataset that we have already. Why we are doing that? We would do without copying that, we would impact directly to the auto data. We don't want to do that error because it's one of the most common errors that the starters are doing. I also did that. I don't deny that. Next step, we're gonna see the columns to refresh our mind. Can use also the log. The columns are remain the same. Then we would love to see the relationship. We already did relationship here. The scatter plot that shows the relationship between the variables, but now it's uncomfortable to go up and down. That's why we're bringing it here. And let's reason which columns, which variables are candidate for the logarithmic transformation. As we see that some of them are ideal candidate for the logarithmic transformation because, as you see, the change here, as you see, some of them has a pattern that makes them an ideal candidate for the logarithmic transformation. As we have told before, what are the criterions for choosing the variables for logarithmic transformation? I would do now with the variables of the displacement, with horsepower, weight, and acceleration. These four. And in order to do that, it's easy. We are just selecting those variables. Then we are gonna use numpy. If you haven't imported yet the numpy, just import it. It's a package of Python as other packages. The difference is numpy is a scientific transformation, scientific usage of the functions are accumulated in this package. We're using the log function of the numpy, and then the remaining is the copy and paste of these guys here, because we are basically changing these guys here, and we are transforming them and saving on them. The next step is for the next step we are going to visualize again our data. So what we're gonna do, we're just gonna use the pair plot to have a scatter plot in order to see the relationship and the change in the relationship. As you see, the difference between those here and this here, this has clear tendency to have the linear relationship between the variables and MPG logarithmic transformation after logarithmic transformation. In order to see visually whether there's a tendency for the linearity, we can draw the linear regressive line. So we are seeing that go through the autolog data and take from that the different functions, and it's gonna be the regressive plot and show us that line. Here's it. The same we can do here too. Don't forget to change the name of the data that you're using. Now we have obvious difference, that the difference is clear, and I'm expecting beforehand to have better results for this one rather than this one. Next, what we are going to is create the two subsets as we did before for the OLS regression. We're going to create the training and testing datasets. We're going to add the constant for these two training and testing exogenous variables set. Then we are going to launch run our relation. Then we are going to run our OLS regression with the transformed data. This is going to be our model. In order to see the summary of our model and see the goodness of it, adjusted I-square, you see that the difference is obvious from 82, if I'm not mistaken, it was 82, we got to 89. Difference on the coefficients are also obvious. So as you see, the more cylinders you have, the more you're consuming the fuel. The more displacements have you, the more you're consuming. That means that the 1 unit change in the horsepower decreases the consumption, the mile per gallon for 0.31, and so on and so forth. If you see today p-values that the most of them now are statistically significant, including the constant. But now the most important part is how it's gonna be reflected on our test model. For the test model, we are using linear model. Log transformed model. And now, most important part, we need to see what's the difference now in the before and now. So we are gonna see this through the test modeling, because on the training data set, it might show the great results, but on the test, it might be not that effective as we thought it is. So that's why we are going to use the logarithmic prediction. It's equal to mean. Logarithmic prediction is equal to the model that we have declared here. Is it? And we're going to use predict. Within the predict, we're going to use the test log. We are running this. Then we want to see the root mean square error for the logarithmic. So we are using the y test values array and the logarithmic prediction. And now the time has arrived, and we're gonna see the results that are gonna really make the impact. It's 0.11. It's a great number. So we had before much more higher results for the testing set. And now we have improved it a lot. It's all because of the transforming the data. So sometimes you don't have to think about the models that are working good or they are not working good. It's sometimes about the data, how they are placed in your dataset.